Probability. An experiment is an observation of a random phenomena. The different possible results of an experiment are called outcomes. The set of all possible outcomes for an experiment is called the sample space. For example, rolling a die is an experiment, and the sample space is whatever outcomes we can get. When we roll one die, we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, or 6. To denote this, we use the curly bracket, which means set. The curly bracket means set with listed elements. So this would be the sample space, set of all possible outcomes. How many we have? 1, 2, 3, 4, 5, 6. Now, when we toss a coin, it is an experiment, and the sample space would be what if we toss a coin, we can get a head or we can get a tail. So we have two possible outcomes, and we denote this in the set. Curly bracket means set with listed elements, element head, element tail. In probability theory, an event is a subset of the sample space. So for example, rolling an even number on a die is an event, and possible outcome would be, what are the even numbers on a die? It's 2, 4, or 6. So this would be my event E. And let's recall what was the sample space. Sample space is all possible outcomes. When I roll a die, I can get 1, I can get 2, I can get 3, I can get 4, I can get 5, or 6. If we look at this, we have 2, we have 4, we have 5. So this event E is a subset of the total sample space, because sample space is all possible outcome. Now, another example, tossing a tail when flipping a single coin also is an event, and we're gonna have just one outcome as tossing a tail. And so this would be my event E. Sample space, when you flip a coin, you can have a tail or you can have a head. So there are two events there. So if you have two, you just take one of them, so it's a subset. Probability of an event E. If we want to calculate probability, probability is always number of the ways the event E occurred divided of number of possible outcome. So N stands for numbers of how many elements is event E divided by number of all possible outcomes. So example 1, find the probability of getting an even number when rolling a die. We just had that example. So even number would be 2, 4, and 6. So this was my event E. Now, how many elements do I have there? I have 1, 2, and 3. So the number of elements in E is 3. So N at E is 3. Now my sample space would be the all possible outcomes. What if we roll one die, what can we get? We can get 1, 2, 3, 4, 5, or 6. How many elements we have? We have 1, 2, 3, we have 6 elements. So the number of elements in the sample space is 6. Now the probability of that event E is gonna be the 3 divided by 6, which is 1/2. So we have 3 divided by the 6, and this gives me 1/2. So probability can be given as a fraction. That would be my 1/2. This is when we divide at 0.5, so we can write the probability as a decimal, or we can also write this as percentage. 0.5 is nothing else but 50%. Let's recall, if you have decimal, to find percentage, we would multiply this times we would multiply this times 100. Example 2, find the probability of getting 2 tails when tossing 2 coins. When we toss 2 coins, what can we get? Let's put in a tree. We can get a tail or we can get a head. That would be my first toss, or one coin. First coin. And then second coin, we can get a tail, we can get a head, we can get a tail, we can get a head. So this would be my second coin. If you remember, how did we list the outcomes? Would be tail and tail. So we have a tail, tail, then we have a tail, head, then we had a head, tail, and we have head, head. So this is all my sample space. I can list them in this way. So how many of them we have? N at S would be, we have 4 elements. Now we ask what is the of getting 2 tails. So 2 tails is 1 out of all of them. So then the probability of event E, we're gonna have it 1 out of 4. And also we could have divided, it would be 0.25 or 25%. Find the probability of getting a sum of 6 when rolling 2 dice. So we would need to list all possible outcomes. We did this sometime in counting in a table. So 1, 2, 3, 4, 5, and 6. This is my 1 die. This is my second die. Also, I can get 1, 2, 3, 4, 5, and 6. And then to list all possible outcomes, we would go that this is my 1 and 1, 1 and 2, 1 and 3, and so on. So we have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. This would be 2, 1, 2, 2, 2, 3, 2, 4, and so on. This would be 3, 1, 3, 2, and we see 3, 3, and we see how this all would go. So how many we have it in total sample space? We have 6 and 6 and 6 and 6 and 6 and 6. So the total would be 6 times 6, which is 36. And this is my number of events in the sample space. Now my event E is what we are looking for. Sum of 6. So this would be my event E. Let's list them. Which one gives me sum of 6? With 1 would be 1 and 5. When I add them is 6. So I need to have 1 and 5. That's my one event. Then on the second one would be what? 2 and 4. So we have 2, 4. Then what can we have on 3? 3, 3. Then we would have 4 needs to go with what? 2 to add it to 6. 5 needs to go with 1 to add it to 6. And we cannot have anything else because 6 would be with 1, it's already 7. So then we count how many elements we have. 1, 2, 3, 4, 5. So the number of elements in event E is just 5. Then the probability of that event E would be 5 out of 36. Example 6. What is the probability in a family with 3 children that 2 of the children are boys? So we list all possible outcomes. For first child, we can have a boy or we can have a girl. This is my first child. For the second child, we can also have a boy or we can have a girl or we can have a boy, or we can have a girl. That's my second child. And for the first child, we can have a boy, or girl, or boy, or girl, or boy, or girl, or boy, or girl. That's my third child. And then to list the events, as you remember, we're gonna go boy, 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 girl, and so on. So we have boy, boy, boy. Then we have boy, boy, girl. Then we have boy, girl, boy. Boy, girl, girl. Then we have girl, boy, boy. Then we have girl, boy, girl. Girl, girl, boy. And girl, girl, girl. I hope we can see it. If we go on this branch, we have girl, boy, boy, and that's girl, boy, boy right here. So then we count how many we have in total. 1, 2, 3, 4, 4, 5, 6, 7, 8. So my total sample space is 8. Number of elements in the sample space is 8. Now we asking what the question asks, what is the probability that we will have the two boys? So we marking the event that has two boys. Two boys right here, two boys are here, and two boys are here. And that's it. No more two boys, right? So how many events? 1, 2, 3. We had 3. So this would be number in event E is 3. Then the probability of the event would be 3 divided by 8. Now, basic properties of probability. Probability is always a number between 0 and 1. What does that mean? Because this is my total sample space. This is my total sample space. My event E is always some part or subset of the sample space. So that means that event E can always be only less than what is the event B, right? And what is the whole event E? Because I'm taking subspace. So in this case, my event E can be at most 8. So 8 over 8 would be 1. It cannot be more than 1, right? And we can also have 0 if we decide what would be probability, in that case, having 4 boys. It's impossible event, right? So the probability is 0 between 0 and 1, or we can think as 0 and 100%. Because 1, when you multiply times 100 to change to percent, would be 100%. Now, probability of an impossible event is 0, and probability of a certain event would be 1. 1, or we can say 100. Here is an example. What is the probability of rolling at least a 1 on a single roll in standard die? At least 1 means that it can be 1, 2, 3, 4, 5, or 6. So this is my event E. How many elements I have? I have 6 elements. So N at E would be 6. But my sample space is also 1, 2, 3, 4, 5, and 6. So in the sample space, we also have 6. So the probability would be 6 out of 6, which is 1. So this is called certain event because when rolling at least one on a single die, we certainly gonna always roll at least one or more. At least one means one or more, right? So that's why we're getting 1. Now, what is the probability of rolling a 10 on a single roll of the standard die? There is no 10 on a die. So this is called impossible event, and in that case, probability of that event would be 0 out of possible 6 outcomes, which is 0. So probability of impossible event is always 0. probability of certain event is always 1. And my probability is always a fraction between 0 and 1. Now, the probability we have demonstrated is also known as theoretical probability because it is derived from the ideal possible outcomes of event. If we actually perform an experiment, such as flipping a coin, and calculate the probability based on the recorded results, this is called experimental probability or empirical probability. So probability calculated from the given data, that's going to be called experimental probability or empirical probability. If the experiment is performed a large number of times, then the experimental probability will be very close to the theoretical probability. So if we talk flipping a coin 100 times or 1000 times, then the number of getting heads would be half as the number of getting tails, because in the theoretical probability we have half of the chances. Example 5. A group of students were asked if they carry a credit card. The responses are listed in the table. So freshmen, 27 of freshmen said that they carry a credit card, where 33 of freshmen said that they do not. Sophomore, it's 41 said that they carry credit card, and 9 of them said that they do not. So this one is experimental probability because it's probability based on survey, based on given data. When the probability is based from data, that's called experimental probability. Now, the student find if a randomly selected student, what is probability that the student is a freshman and carries a credit card. So freshman with credit card is 27. So for part A, we're gonna call it probability. We're gonna call that event A or E. How many we have? Freshmen and credit cards. Freshmen and credit cards is 27 out of total number of students. So total number of students, we need to first add them together. 27 plus 33, that's gonna be 50, 60 students, right? So that's my 60 freshmen. And then 41 plus 9 is 50. So what we have total, 110 students. So this gonna be 27 divided by 110 students. For part B, the student is a sophomore that does not carry credit card. Sophomore without credit card is 9 out of the total number. So for part B, let's call it probability of event B. And in that case, we're gonna have 9 out of 110 students. Because we have sophomore without credit card is 9 out of total number of students. And part C, the freshman, the randomly selected student is a freshman. So we need to look how many freshmen, total freshmen we have. We have 60 total freshmen out of my total number. So for part C, we're gonna have probability of event C is equal to 60 divided by 110. Example 6. A local movie theater surveyed its customers on their favorite type of snack, popcorn or candy. The responses are listed below. So we have adults prefer to have popcorn. 65 adults said that they prefer popcorn, 25 said prefer candy. For children, 15 of them said prefer popcorn, and 45 said that they prefer candy. Now, if a customer is selected randomly from the survey group, What is the probability that the customer is a child and prefers a candy? So we have the child and prefers a candy. We have 45, but we need to have the total number of survey people or people and children. So let's adults and children. So let's add them together. 65 plus 25 is 90. And then we have 15 plus 45 is 60. So we have total 150. If we add 90 plus 60 is 150. So now we can answer part A. Let's call the event in part A as event A. So we have A, probability of event A would be, one more time, customers is a child and prefers candy. Child and prefers candy is 45 out of 150. So we have 45 out of 150, and this we can divide by 15. So we're gonna have 3 out of 10, or we can simply use the calculator, and that's gonna give us 0.3. For part B, the customer is an adult and prefers popcorn. Adult and popcorn is 65. Out of total surveyed people, it's out of 150. Part B, let's call the event in part B as event B, and we have adult and popcorn as 65 out of 150. And if we divide this by 5, we would have 13 divided by 30. So if we use calculator, it's going to be 0.4333 and so on. So we can have it 0.43. In part C, the customer is an adult. So now we need to look how many adults we have in total. So we have 90 adults out of total surveyed people. So for part C, let's call the event C. So we have 90 out of 150. This we can divide by 10, would be 9 out of 15, and divide this by 3 would be 3 out of 5, and this divide is 0.6. So there was almost 60% of the adults that were surveyed out of 150. The concept of odds in probability is a way to express the likelihood of an event occurring, often compared to the likelihood of this event not occurring. So odds we list as a ratio comparing the occurring stuff to the ratio of not occurring. The odds is essentially a ratio or a comparison which is different from the probability. Probability is a fraction representing the chance out of the total number of outcomes. For example, the odds of winning a match is 3 to 2. That means 3 is in favor of winning and 2 is to fail. So odds in favor would be the ratio, the number of ways an event can happen, to the number of ways it cannot, so success to failure. So we have 3 win, 2 lose. But now if we want to calculate probability of winning, we have favorable outcomes is 3. Out of total outcomes, we need to add 3 and 2. So it would be probability is 3 out of 5. So the odds we usually list something that occurs to something that does not, winning to lose. Now, if we would like to calculate against odds, so we have 2 to lose and 3 to win. Probability of losing the match would be 2 out of total number, we have 3 plus 2, which is 5. So probability of losing would be 2/5. Example 7. Some statistics kept by a sport enthusiast shows that the odds in favor of a professional basketball player making a free throw are 9-2. What is the probability that the player makes the free throw? So in favor of making the free throw are 9-2. That means 9 would make, so we have 9-2. That means 9 times we can have it make the free throw, and 2 will not make it. So now what is the total? Total we have 9 plus 2, which is 11. So then the probability of making the free throw, so probability, let's call it event E, would be how many favorable outcomes is 9 out of the total number, 9 out of 11. Example 8. In a particular card game, the odds against drawing a specific wild card on your first turn is 12-8. What is the probability that you will not draw the wild card on your first turn? So we have the odds against drawing. Against drawing is 12-8. That means you will not draw is 12 chances, and that you will draw is 8, right? Because it's against drawing. 12-8 means that against drawing the wild card, the bad card, is 12. So that means, what does that mean? That means you will not draw the wild card. So because that's against, that means you will not. So that means 8 chances that you will get the card. You will get the bad card. So what is the total? Total number of odds is 12 plus 8. In that case is 20. So now we need to see what the question asks. Probability that you will not draw the card. So probability not drawing the card is 12 chances, 12 out of total number of tries. So we have probability of event E would be 12 out of 20. And this we can reduce or divide, would be 0.6. So 0.6 or 60%. This is the 60% chances that we will not draw the wild card. So we need to pay attention. What does the odds says? Odds against drawing. So this is against, and this is in favor of drawing the card. Now the complement event of event E is denoted E prime, and it is not E. And we have that probability of not E is 1 minus probability of E. Also, if you can rearrange this, you can move it the other way. So probability of E would be 1 minus probability of not E. I think that should make sense because both probabilities is going to give us total number of everything what is there. So example 9, the probability of getting D or F in a math 1030 is 1/6. D or F means failing the class. What is the probability of passing the course or getting C or better? So we're gonna have probability of not failing, which is probability of passing, and this is 1 minus the probability of failing. So now we can write it down. 1 is like 6 over 6 minus 1 6, and that gives me 5 6. One more time, 1 is like 1 over 1, change it to 6's, so we would multiply top and bottom of 6. So then the probability of passing the class is 5 6. Or if we want to do it in percentage, if we keep dividing this would be 0.8333, which is 0.83, or you can go 83%. Example 10. The probability that a vaccine you took will protect you from getting the flu is 0.95. What is the probability that you will get the flu? So protect you from flu means you will not get the flu, right? So we have probability of not flu is 0.965. So what is the probability of flu? Would be 1 minus the opposite event, probability of not flu. So this would be 1 minus 0.965. In that case, if we subtract this, so we would have 0.035. So this is the probability. If we change it to percentage, is 3.5%. Probability, in that case, probability of getting the flu if you have the vaccine, of course, right? So this is called complement event. Now, example 11, if there is 1 in 4 chance that it will snow during the morning commute. So snow during morning commute is 1 out of 4. What is the probability that it will not snow? So probability of snow is 1 out of 4. Probability of not snow would be complement event 1 minus probability of snow. So 1 minus 1/4. Then we change that 1 to 4s. It's like over 1 times 4 times 4. We can see that 1 is 4 out of 4 minus 1/4. So this gives me 3/4. Or if we divide this, that gives me 0.75 or 75% chances of not snowing. Example 12. We have a four-sided die and a four-sided die are rolled at the same time, and the sum of the values is observed. So four-sided die looks like this, and we have the 4. Usually we record what is on the top. So this is 4. If we roll it different way, we can record what is on the top or on the bottom. But we have only 4 sides, 1, 2, 3, and the bottom 4. And this is regular 6-sided. So let's see what we can get. Let's list all the events for rolling 2 of those dice. On the one die, we can get it 1, 2, 3, and 4. This would be the 4-sided die. And the 6-sided die, we can get 1, 2, 3, 4, 5, and 6. So now if we go as we did before, we can have it 1, 1. As we had before, we can have 1, 1, 1, 2, 1, 3, and so on, right? So we can have it 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Then we can have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. This row we would have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. And this we can have it 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. So how many total of we have? We have total of 6, 6, 6, and 6. So we have 4 of those 6's, so that means we have 4 times 6, which is 24 events that can happen. Now for part A, we need to check what is the sum of them is 4. If I add 1 plus 1 is 2, so that's not 4. This is 1 plus 2 is 3, so the sum here would be 1 and 4. So for part A, let's call event A to have it listing that the sum gives us 4. 1 and 4 would give us 4. Then what else would be 2 and 2 gives us 4. So 1 and 4. This gives us 6, so that's too much. This is 3 too little. 2 is 4. This would be 5. 2 plus 3 is 5. So then we go to the next one. So 3 and sum of 4. So we need 1 and 3 here. I'm sorry. 1 and 3, right? I'm sorry. So we have 1 and 3, 2 and 2, and then we can have it 3 and 1. And I believe that's all what we can have it to get the sum of 4. So how many we have? 1, 2, and 3. So then probability of event A would be 3 out of 24. And this we can divide or reduce by 3 is 1/8. So probability of getting the sum of 4 is 1/8. Now probability that you roll two the same numbers, let's see for part B, let's call event B to the same numbers. So the same numbers would be 1, 1, 2, 2, 3, 3, and 4, 4. Can we have 5, 5? We don't have 5, 5 because this die has only 4 of the numbers, right? So then if we count, we have 1, 2, 3, 4. 4 out of total number. So probability of event P would be 4 out of 24. If we divide this by 4, the probability is 1/6.